Today, we're going to talk about standard form and vertex form of a quadratic equation. First, we're going to talk about standard form. So you see on your screen here, ax squared plus bx plus c is standard form of a quadratic equation. What we're really going to focus on here is what the a tells us about the graph of the quadratic equation, or the parabola, and what C tells us about the graph of the quadratic equation. We're really not going to focus on B. So here, when we have ax squared plus bx plus c, the value of a tells us two things. It tells us what direction the parabola is going to open. So is it going to open up or is it going to open down? And then it tells us the width of the parabola. So will the parabola be narrow or will it be wide? So if A is positive, that means the parabola will open up. And we've already learned that if your parabola is opening up, that means the vertex of the parabola is a minimum. The vertex would be the lowest value or the lowest point on the parabola. Now, if this A value is negative, that means our parabola is going to open down. And like we've previously talked about, if your parabola opens down, then the vertex, or the point where the graph changes direction, the turning point, is a maximum. Now, we talked about in the stations what happens when A is a number bigger than 1 and when A is a number smaller than 1, so like a fraction. So here we're going to look at if the absolute value of A is greater than 1. Remember, absolute value is the distance something is from 0, and it's always positive. So if the absolute value of A is greater than 1, then the parabola will be narrow. So if you look at an example, like the absolute value of 2 is 2, which is greater than 1. So if your A value is a positive 2, your parabola will be narrow, compared to the parent function y equals x squared. Now, the absolute value of negative 2 is positive 2 as well. Remember, absolute value is distance from 0. It's always positive. So if our A value is negative 2, that means our parabola will open down, but it's still going to be narrow because its absolute value is greater than 1. Now, if the absolute value of A is less than 1, which means it's a fraction like 1/3 or 1/4 or 1/5, or a fraction like negative 1/3 or negative 1/4 or negative 1/5, because all of those values have an absolute value less than 1, then the parabola will be wide. So let's say our A value was negative 1/2. That would tell us that the parabola would open down because our A value is negative. But the absolute value of negative 1/2 is positive 1/2, which means the parabola will be wider than our parent function y equals x squared. In standard form of a quadratic equation, so when we're looking at ax squared plus bx plus c, c tells us the y-intercept of the quadratic function. So c is the y-intercept. If the y-intercept is positive, that means our parabola has shifted up from the parent function. On our parent function, y equals x squared, the y-intercept is 0. Okay, remember the y-intercept was 0. So if your parabola has a positive c value, that means the parabola has moved up on the coordinate plane. If the y-intercept is negative, then the parabola will have shifted down from the parent function. So standard form of a quadratic equation is useful because it lets us see the direction the parabola opens and the width, and it shows us the y-intercept without having to graph. Now we're going to look at vertex form of a quadratic equation. So vertex form is a times the quantity x minus h squared plus k. Vertex form is very useful because, like the name states, it allows us to easily identify the vertex of a quadratic equation, the vertex of the parabola, which will make it easy to graph. So, just like in standard form, A also tells us the direction and width of the parabola in vertex form. So here, this entire box is the same as what we went over. So if A is positive, we know the parabola will open up. If A is negative, then the parabola will open down. If the absolute value of A is greater than 1, then the parabola will be narrow. And if the absolute value of A is less than 1, then the parabola will be wide. H in the quadratic equation in vertex form, A times the quantity x minus h squared plus k, h represents the x value of the vertex. So in our notice and wonder stations, we looked at what happens when you add or subtract numbers inside the parentheses. And we said, hey, it changes how the parabola moves to the left and to the right. So h is the x value of the vertex. This h value causes the parabola to shift left and right. If we are subtracting h inside the parentheses, then the parabola will shift to the right. Okay, you move the opposite direction of the sign when you are inside the parentheses. Which means if we add h inside the parentheses, the parabola will move that many units to the left. If h is the x value of the vertex, then it makes sense that k would be the y value of the vertex, because this is vertex form of a quadratic function. So k, the number that you add or subtract at the end here, is the y value of the vertex. In our notice and wonder stations, we saw that adding or subtracting a constant outside of the parentheses shifted the parabola up or down. So k causes the parabola to shift up or down. If we subtract a constant k outside the parentheses, then the parabola will shift down. If we add k, a constant k, outside the parentheses, then the parabola will shift up. So when we're discussing the y value of the vertex, the parabola moves in the same direction as the sign. If you are adding this k value, the parabola moves up. If you subtract that k value, the parabola moves down. Now, it is very important to note here that k in vertex form of a quadratic equation is not the y-intercept. So in standard form, plus c, the constant c that's added at the end, is the y-intercept. But in vertex form, this k value, the constant that's added here, is not the y-intercept. It is the y value of the vertex. Vertex form of a quadratic equation is very useful because not only does it allow us to see the direction the parabola opens up and the width of the parabola, it also allows us to easily identify the vertex. So the formula for the vertex here would be the ordered pair h, k, where h is the x value of the vertex and k is the y value of the vertex.